Section 8.1 is monomials and factoring. In this example, when it says to factor completely, that means we want to write the prime factors of 20x to the cube y to the squared. The prime factors of 20 is 2 times 2 times 5, and x cubed is x times x times x times y times y. Example B, 34, that is 2 times 17. Example C, negative 52, a to the second b. You have to bring the negative over and just put it with the first term. Negative 2. 52 is 4 times 26, and 4 would be broken down to 2 times 2. Or 2 times 26, and 2 is 2 times 13. Example 12, to find the GCF of each term, to have two numbers, you find the GCF of the two numbers. What's the greatest common factor of 12 and 18? That would be 6. And remember, when we're finding the GCF of a variable, it is the variable with the smallest exponent. And obviously the variable has to be in both terms. So we have an a squared and an a, so it'll be an a. We have a b to the second and a b to the third, so it'll be b to the second. We have a c in this term, but we don't have a c in the other, so c is not part of it. Example B, GCF of 6 and 18 is 6. We have an x in the first term, but not an x in the second term. We have a y cubed, and we have a y, so it's y. We have a z in the second, but not a z in the first. So my GCF is 6y. And example C, the GCF would be 10 q to the second RT. Use the distributive property to factor out the GCF. Now remember, the directions in the book says use the distributive property to factor each polynomial. I like these directions better. So step 1 is you find GCF. My GCF in this problem is 3. Pull it out. Of the polynomial. And then step 2 is divide the GCF into each term. So 3 goes into 15y, 5w, minus, and then 3 goes into 3v, 1v, or we could just say v. Example D. Now you got to be careful about this one. There's a 7, and 7 goes into 21, but there's not a number in the last term, so we don't have a number GCF. We have to go straight to the letter. My GCF would be a U and a T. So we don't have anything to divide the number with, so we get 7. When we divide variables, we subtract the exponents. We get U, T, plus 21. U goes into U evenly, and T goes into T squared T times. Remember, again, we subtract the exponents. Now the minus. UT goes into UT evenly. We have to put something. You just can't leave it. We have to put a 1. If everything goes away, you have to make sure you put the 1. Example 2, we're going to factor by grouping. When we factor by grouping, we group the first two together, and we group the last two together, and make sure you have a plus sign in between. Step 1, pull out a GCF in the first group, which would be a 4R. and we get Q plus 2. In the second group, make sure you bring down the plus sign. Second group, I'm going to factor out a 3 and get Q plus 2. Now, my GCF are these two, what's in the two parentheses. They become 1. And what is left over? 4R plus 3. Example 3, I'm going to group my first two together, group my last two together. My GCF is 3A, and I get B minus 5. The second group, I'm going to factor out a 4, and I get B minus 5. Now, again, my GCF is the two binomials, the two groups, two parentheses. And what do I get left over? 3A plus 4. Example C, group the first two together. Now make sure you have that negative inside the parentheses. Now I'm going to factor out an N and get R plus 5. Now be very careful here. If your first term is ever a negative, you're going to factor out a negative. So in this case, you could bring down the plus and then factor out a negative, but what's the plus and negative make? A minus. And when you factor out a negative, you change the signs. And then we get R plus 5 times N. Oops, I'm sorry. You have to factor out a negative 1 in this case because we don't have a GCF. Okay, example D, I'm going to group the first two together. I get a 3P. I get N plus 5. Now again, my first term is a negative, so I have to factor out a negative 4. And remember, when you factor out a negative, it changes the sign, so that's a plus 5. Be very careful about that. I factored out the N plus 3, the N plus 5, and I get 3P minus 4 left over. Example 3A, if I factor by grouping, I'm going to factor out a 2M, I get K minus 6. I'm going to factor out a 7, and I get 6 minus K. Now, these are reversed, what's called an additive inverse of each other. I think it's a little bit easier if we just scratch this out, rewrite the problem. I'm going to erase it. Rewrite the problem, flipping the last two set terms. I think you're less likely to make a mistake if you do it this way. Group the first two together. Negative has got to be inside. Group the last two together. And I get 2 M. Oh, sorry. I'm supposed to factor out an M. I get K minus 12. Again, I'm going to factor out a negative 7. And remember, when you factor out a negative, you change the signs. Oh, sorry. It should be a 6. So now I get K minus 6 times 2M minus 7. Example C, factor the group first two and the last two, and I get a C. I get 1 minus D plus 4 times 2D minus 1. Okay, these are additive inverse of each other, so what I'm going to do, I'm just going to erase it and rewrite, flipping the second terms. Group my first two together. I get a C, 1 minus 2D. Now I'm going to factor out a negative 4 and I get 1 minus 2d. Somebody asked me the other day, I said, what if you can tell already before you even start that it's going to be an additive inverse and you need to flip the second two terms? If you can see that going into it, absolutely. I'm not always sure if I can or not. So I'm just going to do it the long way. Factor out a negative 9 and get 2p. Okay, now I can see that it's already, so I'm going to go ahead and stop right there. Group the first two, group the last two. I'm going to factor out a p and get 3 minus 2p. Factor out a 9 and get 3 minus 2p. Now I'm going to pull out a 3 minus 2p times p plus 9. Example 4. Now, this is called the zero product property. When you have two factors are what you multiply together, a times b. A is a factor and b is a factor. When you have two factors that you're multiplying together to get 0, and it's equal to 0, you just take each factor and put each one equal to 0. So in example 4a, it's kind of like it's already factored for you. So you already have the two factors, so you just drop them out of the parentheses and put each one equal to 0. And solve. So we're going to subtract 6. 2d is equal to negative 6. Divide by 2, and d is equal to negative 3. Add 15. So 3d is equal to 15. Divide by 3, and d is equal to 5. Now in example B, it's not equal to 0. So what we're going to have to do is put it equal to 0. So we're going to have to subtract, move the 3c, so we're going to subtract. Now these are not in factored form. It's adding or subtracting. It's in a polynomial. So what we're going to have to do is we're going to have to factor first. And we're going to factor out a GCF, which is C. Now it is in factored. Now there's two factors, so we put each one equal to 0. Add 3, so C is equal to 3. Example 4c, it's already factored for you. So we put each factor equal to 0. We're going to divide by 3. So n is equal to 0. And then subtract 2. So n is equal to negative 2. Example D, as you can see, these are terms. They're not factors. Terms are numbers that we're adding or subtracting. Factors we would be multiplying. So we're going to factor first. We are going to factor out a GCF of 8b and get b minus 5 is equal to 0. Put each one equal to 0. Divide by 8. B is equal to 0 and b is equal to 5. And that is the end of section 8.1 and 8.2.